15, right?
15.
A to the power 4, then x squared plus 20, alright? 20 a to the power 3 x cubed, alright? Then plus 15 a squared x to the power 4, right? Then plus 6 a to the power 1 x to the power 5. You notice the sum of the power must always be equal to the power of the given binomial function. Alright? Then the last term is 1 x to the power 6. Alright? But this method of expansion, you notice, will become very tedious. Alright? When n is a very big positive integer number. Alright? Become very tedious, alright, and cumbersome, alright. Therefore, we need a better method to expand a binomial function, alright. So, a better method will be using the binomial theorem, alright. Using the binomial theorem, right. Before we discuss the theorem, let us take a look at this combination of m objects taken r at a time, which you have learned in additional maths. Alright? The combination of n objects taken r at a time is denoted by this NCR or bracket NR. Alright? It's a column matrix, let's say NR. Alright? Which is equal to n factorial over n minus r factorial times r factorial. Can you still remember this?
Yes.
Okay, alright. Okay, good. N factorial is defined as n times n minus 1, n times n minus 2, continue multiplying until 1. Alright? Example, 5 factorial is 5 times 4 times 3 times 2 times 1. Alright? So by convention, we are taking 0 factorial as 1. Alright? That is by convention. And we can show that n Cn minus r is equal to nr. Alright? This can be shown by using the definition for NCR. Alright? Alright, so if you want to show Cn minus r is equal to NCR, we use the definition. It is n factorial over n minus r factorial. Then multiply to n minus r factorial, correct? Using the definition for NCR. Now r is replaced by n minus r, alright? So you get this. So this can be simplified as r factorial, right? When you open bracket, it becomes r factorial times n minus r factorial. So you have learned multiplication is commutative. Therefore, this can be written as n factorial over n minus r factorial times r factorial, which is your NCR, alright? Which is equal to NCR, alright? So you observe that the coefficient in each expansion here, you notice is actually the combination of either A or X. It's either A or X. For example, in the expansion of A plus X cubed, right? So the first term is A cubed, right? First term is A cubed. Hence, we can take the coefficient as either combination of A or combination of X. The combination of A will be 3C3, right? 3C3. Combination of X, because there's a 0X here, therefore it will be 3C0. Alright? 3C0. Do you notice that? Okay? And then this coefficient is equal to, let's say we take it as combination of X, will be 3X here, we choose 1. Correct? 3X, we choose 1. Therefore, is 3C1. Alright? And then the coefficient of the term here, if we take combination of X, will be, out of 3x, we choose 2. Alright, we choose 2, therefore it's 3c2. Alright, and then for the last term, the coefficient is a combination of 3x taken 3 at a time, so it's 3c3. Alright, 3c3. You can use calculator and work out. You notice 3c0 is 1, 3c1 is 3, and 3c2 is 3. Because there's a symmetry which I have shown you just now, right? NC n minus r is equal to NCR. Alright? Because of the symmetry. Therefore, we have this coefficient 3c1 equal to 3c2. Alright? And then plus 3c3. Alright? Which is 1. Okay? So similarly for this expansion a plus x to the power 4, you notice the coefficient of this is equal to 4c0. Alright? We take it as combination of x. Alright? We take 0 out of 4x. Okay? So it's 4c0. And the coefficient of this term, that is 1x here, right? So we choose 1 out of 4x. Hence it's 4c1. Alright? 4c1. And this we choose 2 out of 4. Therefore it's 4c2. Alright? And for the fourth term, we choose 3 out of 4. So 4c3. And finally, 4c4. Right? So the coefficient in the expansion of a binomial function, therefore, can be obtained this way. Alright? As either combination of x or combination of a. So normally we choose the combination of the second term. Alright? Hence, in general, you have expansion of a plus x to the power of n, where n is a positive integer. Alright? Where n is a positive integer, so you will get first term, which is a to the power of n. Correct? A to the power of n, and the coefficient is nc0. Alright? nc0, followed by the second term is nc1. Alright? A to the power n minus 1, x to the power 1. Alright? The power of a will decrease by 1 each time, and while the power of x increase by 1. Alright? And the sum of these two powers is always equal to the power of the given binomial function. Alright? Then the next one will be nc2. Right? A to the power n minus 2 x squared. Alright? So the r plus 1 term here. Alright? The r plus 1 term here, therefore, will be NCR. Right? NCR, a to the power n minus r, x to the power r. Alright? That is the r plus 1 term in this expansion. Alright? And then plus, the last term will be NCN. Alright? NCN, x to the power n. Alright? So, in general, the terms in the expansion of a plus x to the power n will be this. Alright? So this is what we call binomial theorem. Alright? So what other characteristic do you observe here? Beside the powers, sum of powers is always equal to the power of the given binomial function. Beside this, what else do you observe? Anu? What else do you observe? N is a positive integer, right? N is a positive integer. So we notice that the number of terms in this power series is finite. Alright? Is finite. And how many terms are there in this expansion? There are n plus 1 terms. Alright? There are n plus 1 terms. That means the number of terms in the expansion is always